Continuing our discussion on iterations, I want to do a couple more examples of iterations using the for loop. Once again, I'm going to develop these in two different styles: direct access style and indexing style. Okay. All right, so this particular example, we're going to get a vector called grades, and it's going to contain a set of grades. Let's just use A, B, C, D, and F. And we're going to calculate, we're going to return a vector. At the end, we're going to have a vector, and it's going to contain the quality points associated with each grade in this vector. Okay? So we'll do a vector that's going to hold our results. We'll call it Q points. And just like in the previous example, we'll make it the empty vector. So we're going to start off with the empty vector, and as we loop through, we're going to fill this vector with the Q points, the amount of quality points corresponding to each one of these letter grades. Okay? So we're going to set up our for loop, and we'll say for some variable x equals the vector grades. So x is going to equal, every time through the loop, it's going to equal each successive value in the vector grades. And we want to make a decision on each one. So this time, and these are discrete values, so this time I'm actually going to use a switch statement. And we're going to switch, do our switch. Oops, that is wrong. We're going to do our switch on the value of x. Okay? So each time through, x is going to equal each successive value in the vector grades, and we're going to evaluate that value and assign a corresponding quality point value inside the vector Q points that we're going to build up through concatenation. So my first case is if x equals a, then my method here is I'm going to create a variable called this quality point is going to equal 4. Then next case is that x equals b, and this QP is going to equal 3. In case x equals c, this QP is going to equal 2. In case x equals d, this QP is going to equal 1. And in case x equals f, this QP is going to be 0. I'm going to assume that this is all going to behave properly, so I'm not even going to put an otherwise in here. I will end my switch statement. Then, before I exit my for loop, I need to build the vector Q points. And so I'm going to say vector Q points is going to equal the concatenation of the existing value of Q points concatenated with the variable this QP. And so this QP, the variable this QP, will get assigned one of these 5 values every time through the loop, and then that value will get concatenated onto our result vector Q points. Okay? And then I end the for loop, and then I can display the vector Q points once I'm finished. Okay? Alright, so here, since I ran a space down low, I'll put my simulated command window over here. Okay? And so here we go. So grades equals this vector. Q point starts off being empty. And so for x equals grades, so x is going to be each successive value in the vector grades. So the first time through, x is going to be a. I switch on x. So in case that's a, then this QP equals 4. So this QP is going to be 4, right? I finished my switch statement this time around. Q points equals Q points. So vector Q points is equal to what was the empty vector concatenated with A. So now Q points equals a vector with A in it. Okay? Next time through, and so I do that, I end, I go back up to the top of my loop. Next time through, X now equals B. So I do my case B, so this QP equals 3. So I end my switch statement. Q points, now Q points equals what it used to be, which is the vector A concatenated now with the scalar this QP. Whoops, I did that wrong. I'm sorry. This was a 4. This was a 4. This was a 4. Now it's concatenated with the value of 3. Okay? Sorry if that confused you. Then I end. I go back up. Now X is equal to C. I do my switch statement. C says this QP equals 2. So now Q points equals the old vector 4 and 3 concatenated with the value 2. So now Q points equals the vector 4, 3, and 2. Okay. Now I go back up to my loop. X now equals D. So I do this. So now I get this QP equals 1. So now Q points, run out of space here, equals the vector 4, 3, 2 concatenated with 1. So let me skip down here. Q points is now equal to the vector 4, 3, 2, 1. Go back through. X is now equal to F. Q points, I come down here in my switch statement. This QP is equal to 0. And so now I concatenate that on the end. And so Q points, the new value of Q points is equal to the old vector 4, 3, 2, 1 concatenated with the value 0. And so now Q points equals the vector 4, 3, 2, 1, 0. I go back up here. I've reached the end of my vector. I'm done with my for loop. And so now I display Q points. So what gets displayed is 4, 3, 2, 1, 0. And these are the corresponding Q quality points for these particular grades. So that's what's going on in this loop with the direct access. Let's see the implementation over here. In the indexing method, setup is the same. Q points is an empty vector. Now for X, because it's the indexing method, X is going to equal the indexes of this vector, which are 1, 2, 3, 4, and 5. Okay, so X is going to be 1 colon, once again, the length of vector grades. So now when I do my switch statement, I'm not switching on X, I'm switching on grades indexed at X. And that really is the only difference between these two pieces of code. I'll go ahead and write it out. Case A, this QP equals 4. Case B, this QP equals 3. Case C, this QP equals 2. Case D, this QP equals 1. Case F, this QP equals 0. In that, do my concatenation statement here to build my vector Q points equals concatenation of Q points in this QP. And then I end my for, and then I possibly want to display vector Q points. Okay. So now going through this, once again, grades equals the vector A, B, C, D, F. Q points equals the empty vector. For x equals 1 to the length of grades, so x is going to be the values 1, 2, 3, 4, and 5. I come down here, I'm going to, so the first time through x is going to be 1. I come down here and I do my switch on grades indexed at x. So grades are going to be, grades this vector here indexed at x. In this case, x is 1. So grades indexed at 1 is a. So we're switching on the value a. In case that value is a, then this QP equals 4. This QP now equals 4. My QP, let me give myself some room this time. Quality points is going to equal my old quality points, which is the empty vector, concatenated with this QP, which we've determined to be 4 now. So that's the value 4. So now my quality points equals the vector 4. I end, I go back up to the top of my loop. Now x equals 2. So now I'm switching on grades indexed at 2. Like grades indexed at 2 is the value b. That case says that this QP is 3. I go down here, my quality points, so Q points, it's going to be my old value of Q points, which is the vector 4. It's concatenated with this QP, which is now 3. The value of this QP is now 3. So therefore, Q points now equals the vector 4, 3. I come back up to the top, x is now 3. It indexes, so switch grades indexed at 3 is C. I do my case, this Q points, this QP is now 2. So I go down here and I do my concatenation. Q points equals the old Q points here, which is 4, 3, concatenated with the value of this QP, which is 2. So now Q points is equal to the vector 4, 3, and 2. Go back up here to the top, x is now equal to 4. I index grades at 4, that's D, and so the case is that this QP is now equal to 1. So I do my concatenation here, Q points equals the old value of Q points, which is 4, 3, 2, concatenated with the value of this QP, which we just determined is now 1. So now Q points is the vector 4, 3, 2, 1. I go back up here. X is now its next value, which is 5. Grades indexed at 5 is F. Case F is this QP is now 0. So Q points equals the old vector 4, 3, 2, 1, concatenated with the present value of this QP, which is now 0. So now Q points equals the vector 4, 3, 2, 1, 0. Okay. You end. Now you've reached the end of this vector. X has been all the values in this vector. So you exit the for loop and you come down here and you display in the command window the value of Q points, which at this point is the vector 4, 3, 2, 1, and 0. So that is a very detailed explanation of this code. It's using a lot of things. It's using this concept of vectors, of course, up here. It's using the concept of the empty vector here. It's introducing the for loop from the direct access style over on this side, the for loop using the index style over on this side. It is showing how to use the switch statement, which is here, right? It's showing down here on these lines how do you build a vector, a result vector, by concatenating the new value onto the old value. Okay? And then it's showing the display function here. You display things to the screen. So this is a very good example. We're also going to do this in MATLAB both ways as well. I got one more example I want to show you. And I'll show it using both the direct access and the indexing styles. As well. Okay, so this particular operation is also one that's done a lot. This is why I want to point it out here. It's trying to find the maximum value in a vector. Now you could also do the minimum value in a vector. And of course, you could just use the built-in function max or the built-in function min. You could use those, they'll be fine. But once again, like I said in the introduction, a lot of things that are built into MATLAB are the iteration functions. And so by redoing this, it'll help your understanding of what's going on in MATLAB and also give you some context to explore this iteration. So we're going to actually write our own. We're not actually going to do a function, we're going to do a script here. Okay, so let's say we have some vector v, and it equals 26, 42, 87, 13, and 5. Okay. So what we're going to do is we're looking for a value. So we're going to accumulate the maximum value. And so our strategy is we're going to look at the first value, and we're going to set some variable. I'm going to call it maxi. We're going to set some variable maxi equal to this value, the first value. Then we're going to compare that value with the next value. And if that value is greater, then we're going to put that value into the variable maxi. So as we encounter each variable, as we encounter each value of this vector, we're going to compare it to our pre-existing maximum value. And if it's greater, then that value now becomes the new maximum. So by the time we hit the end and we've gone through every value, then we would have found the maximum. And so that's the strategy. And so I'm going to say some variable maxi is going to equal the first value in vector v, which is v1. Okay? So that means now max equals 26. For, here comes our loop. We've got to get through every value here, so we're going to do the for loop. And so we're going to say for x, and we're using direct access, so x is now, going to equal every value in v. But we don't want to start with the first one because we've already set the first value equal to maxi. We want to start with the second one. And so we're going to start with for x equals v, not all values in v, but from the second value in v to the end of v. So this time the for loop is going to start here and not here because we've used that first value already. Okay. Now our test using the if statement. If x is greater than maxi, if it's greater than our present value of maximum, then now maxi is going to be the value x. End our loop, and just so we have something to do down here, display the value of maxi. Okay. All right, so let's go through this one. We come in, v equals this variable, it equals this vector here, maxi. So the value, and let me keep that over here, the value of maxi is now going to get 26 because that's v indexed at 1. Then for x equals v 2 to n, so x is going to go from the second value in v to the last value in v. So now x now equals the value 42. If 42 is greater than maxi, well, maxi was 26, and so yes, 42 is greater than maxi, so now maxi equals 42. Okay, we go back up to the loop. Now x now equals the next value in the vector, which is 87. Is 87 greater than the present value of maxi, which is 42? Yes, it is. So now maxi equals 87. Now equals x, which x was now 87. So we go back up to the loop. Now x is the next value in the vector. So is 13, if 13 is greater than maxi, well, maxi's 87. Is 13 greater than 87? No, it's not. So you do nothing. You come back up. X is now equal to the next value in the vector, which is 5. If 5 is greater than 87, is 5 greater than 87? No. So you don't do this part, and you come back up. You've reached the end of your vector. You come out, and now you display, command window once again, you display the value of maxi, which is 87. All right. And so that's a common way to do maximum problems using iteration. Let's show it over here, just for completeness sake. Let's show that over here with the indexing style. Same vector, v equals 26, 42, 87, 13, 5. We're going to do maxi equals v sub 1. And then we're going to do indexing method. So 4x equals 1, the vector 1 to the length of vector v. Okay, which now x is going to go through the vector 1, 2, 3, 4, 5. Okay. All right. And we're not going to test to see if x is greater than maxi. We're going to test to see if v indexed at x is greater than maxi. If that's the case, maxi is not going to get the value of x. It's going to get the value of v indexed at x. Once again, that's why we call this the indexing style. Then we'll end our if, end our for, and then we'll display maxi here. All right, so let's look at this. We come through, this is v, maxi equals v sub 1, so maxi gets the value 26. For x, so actually this is incorrect. We don't want x to go 1 through the length. We want x to start at 2. And so it's going to go from 2 to the length. So instead of starting here at 1, x is actually going to do this, right? Because we've already set maxi to this one, so we can start here at the second element. So the code is x equals 2 to the length of v, right? And so x equals 2 the first time through. So if v indexed at 2 is greater than maxi, well, is v indexed at 2 greater? Is 42 greater than 26? Yes, it is. So maxi now gets the value of v indexed at 2, which is 42. You end that, you go back up to the loop. So now x equals the next value in this vector, which is over here, which is 3. If v indexed at 3 is greater than maxi, so v indexed at 3 is 87. Is 87 greater than 42? Yes, it is. So now maxi equals v indexed at 3, which is the value 87. Right? So now you come back here and you go back up. Now x is equal to 4. If v indexed at 4, v indexed at 4 is 13. Is 13 greater than 87? No, it's not. So skip that. Come back up. You're now at x equals 5. If v indexed at 5, which is the value 5, is greater than maxi, which is 87, is 5 greater than 87? No, it's not. So you don't do this. You finished with this list here, so you exit out, and now you display maxi in the command window, which is 87. Once again, the direct access style and the indexing style of implementing this algorithm using the for loop. Okay? All right, and then now I'm going to do this in MATLAB on the video so that you guys can see it in action in MATLAB. Third example of iterations, for loops. I'm going to do the Q point calculation, or the Q point calculation script that I did on the board. So let's get right to it. Some clean slate stuff here. And then put some notes in here so we remember. So this particular code, we're going to use a switch statement, and so we'll get some vector grades. Try to save some space here, so I'll just call it G, A, B, C, D, and F. So press that, and then we're going to get our vector that we're going to accumulate our results in. So that's the empty vector. Now we're going to loop through vector G, so X is going to equal G. So it's going to loop through every value of G. Now we're going to set up our switch, and we're going to switch on the value X, and we're now going to do a bunch of case statements. So case A, this QP equals 4. Case. Also, what's to note here is that MATLAB's sort of nice is that you don't have to really work to do the indentions. It sort of is doing them for me. And when I type in case after the switch statement, it sort of knows exactly where to put it. So watch, as I type in case here, it shifted it back over and actually highlighted the switch statement. So I know that that case goes with the switch. So if you pay attention to the MATLAB screen, it does give you a lot of help. Oops. Equals 2. Go back up here. Make sure that's capital. Okay. And then I'm also going to need a little bit more space coming down here. So let's do it like that. Yeah, this is a long script here. So my next case, D is QP equals 1. Case F is QP equals 0. Okay? And then we end that switch statement. And then below that, I'm going to put the building of Q points. Q points equals Q points concatenated with this QP. So the switch statement selects what the value of this QP is going to be, and then we concatenate it onto the Q points vector in line 21 here. So then after that, we're going to end the for statement, and then let us display Q points once we finish. Okay? So that should do it. There's a little bit of space here. Okay, so I've already saved it, so I'm going to execute it. Let's go ahead and let's put our breakpoints in here. Clicking over here. Okay. All right, so now we execute it, and we see that vector. So we're here at line 6. We click on it. G got assigned the vector A, B, C, D, F of type character. This looks a little bit different than our vector of numbers. We'll get to this in the lecture on strings. But for right now, just accept that that's the vector there. Q points, as we step through, is going to be the empty vector of type double. We're going to do switch on X. So X is going to get the first value in G. which is the character A. It jumps down here to line 10, checks that case. It is true, so it jumps to line 11, and this QP gets assigned 4, as you see here. And then it's finished with the switch statement, so it jumps all the way down to line 21, where now it's going to begin to put together, by concatenation, it's going to put together our result vector Q points. And so it does that. Now Q points is the vector, and it has a 4 in it. Okay. I now go back up to the top of my loop on line 8 because I'm not finished with X has not become all the values in G yet. And so I go back up to line 8, and now X equals B. And you notice I do a switch on X. I go down to 10 to see if it's equal to A. It is not, so it jumps now to line 12. It is equal to B, and so it will execute line 13. And then this QP will now be 3. And so it jumps, it's finished inside the case. It found the case that's right, so it jumps down here to 21 and concatenates 3 onto the vector Q points. Goes back up to the top of the loop again. Now X equals C. And so now it's going to check on line 10 to see if X equals A. It does not, so now it jumps to line 12, skipping over line 13, jumping to line 12 here, and see if case equals B. It does not, so it skips that. Skips line 13, jumps to line 14 to see if X now equals C, and it does. So then it's going to execute line 15. Now this QP becomes the value 2. Jumps out of the switch statement because it's found the right value, comes down here and concatenates the value 2 onto vector Q points. Goes back up on line 9. Now X is equal to the next value in vector G, which is D. So X equals to D. Test on line 10. No. Test on line 12. No. Test on line 14. No. Test on line 16. Yes. So now at line 17 is executed. This QP now equals 1. Jumps down here to line 21 outside the switch statement, and now it concatenates that 1 onto the vector Q points. Not finished yet going down G, so it comes back up to the top of the loop on line 8. Now switch equals F. So it does the test on line 10, no. Test on line 12, no. Test on line 14, no. Test on line 16, no. Test on line 18, yes, so now it executes line 19. Now this QP equals 0. Jumps to line 21. Q points equals Q points. Concatenated with this Q point, so the 0 now gets concatenated to the end of Q points. It now will exit the loop because it has done all the values in vector G and goes down to display Q points, and now the Q points get displayed to the screen down here in the command window. So that is the execution using the direct access method. For completeness, let's jump over here to a new window. Need some more space here. And let us do the same thing. Split the window this way. And let us do the same thing using the indexing method. All right. So we're going to go over here and do clean slate. And we're going to clear all. And then we're going to clear our command window. And we're going to put in a note, calculate quality points using Q points using indexing. Okay, so indexing style. G equals, put our vector together again. Suppress it with a semicolon. Our results vector. Suppress it with a semicolon. Now, once again, for X, X is not going to equal G. It is going to equal the indexes of G, which are 1 through the length of G. Now we're going to put our switch statement in, and we're not going to switch on X. We are going to switch on G indexed at X. Okay? All right. And then we're going to do our case statements again. So this is going to be absolutely identical. So I usually don't do this, but I'm going to copy paste this in here. So this is going to be exactly the same code as it was in the direct access. Once again, once we've accessed the value in the vector using the indexing, and then this QP is going to get set to the appropriate values here, then we no longer need, then these two pieces of code become exactly the same. Okay? So now I copied and pasted all this case statement stuff over here because it is exactly the same, and I wanted to prove that point that it is the same, that we could copy and paste it over once we got our indexing. So now we're not switching on X, we're switching on G indexed at X, because on line 8 we set X up to be all the indices that will get us through all the values of vector G. Okay. All right. So we're going to, let's set our breakpoints so we can see this one execute as well. And X is going to go from the values 1 to 5 here, because there are 5 things in G. All right. So I've already saved it once again. So let's do this. Step through. G equals vector A, B, C, D, F. Step again. Q points is the empty vector here. Step again. X equals 1, because the first value in the vector 1 colon length G is 1. And now we're going to switch on G indexed at 1, which is the value A. And so line 10 will be true, so we'll execute line 11. And you see here that this QP gets the value of 4. And now on line 21, we add 4, concatenate 4 onto the empty vector in Q points. And so now Q points is the vector with 4 in it. Go back to the top. Now X is changed, indexed to 2. So when we click, which is now G of X will be the value B. So now we click there. It's going to fail the case on line 10, so to skip over line 12, it will be true there. So now it executes line 13. This QP now gets the value of 3. You jump down to line 21, and now the value of 3 will get concatenated onto the vector Q points. Start again. This time X now equals 3, so we'll be indexing at G sub 3, which is the value C. So we skip over line 10, skip over line 12, execute line 14. This QP is now equal to 2, which you see here. Click again, and Q points gets concatenated with 2 right here. Okay. So now back to the top, X equals 4, so you're going to index at the 4th value, which is B. Skip over 10, skip over 12, skip over 14 because none of those are true. Go to 16, that's true, so you execute line 17, and this QP will now equal 1 here. And then now Q points gets 1 concatenated onto it at line 21. Go around again because you haven't finished going down the vector 1, 2, 3, 4, 5, which is indexing G. So now X equals 5. You index G at 5, that is F. So you'll skip over the case in 10. You'll fail the case at 12. You'll fail the case at line 14. You'll fail the case at line 16, which is D. But line 18, since the value of G sub X is now, or G sub 5 is now F, you will pass that test, so you execute line 19 here. This QP will be 0, as it is here. And then on line 21, it will get concatenated on the Q points, like there. We finished going through our loop now, so now we'll display, and as you can see down here in the command window, vector Q points is vector 4, 3, 2, 1, and 0. So next up, we're going to do one more example, which is a common thing to do, which is to find the maximum in a vector using iteration. Once again, it's built in MATLAB, but we're going to explore it in the next video. Last example with introduction to for loops and iterations, but iteration with the for loop. I'm going to do a common problem, which is finding the max value that's in a vector. Once again, yes, the max function is built into MATLAB. However, this is a good way to illustrate. The max function in the iteration with MATLAB. So I'm going to start as I do before. Let's do a clean slate. Oops. Okay. So clean slate and we're clear. Now all. Let's clear all. And we're going to do CLC, clear command window. And this is the max with direct access style. And so let's take a vector. Let's use V this time. 26, 42, 87, 13, 5. Let's press that with the semicolon. Define a vector maxi. Excuse me, not a vector, a scalar maxi. And we're going to initialize maxi to be the first value in V, and then we'll compare every other value. We'll go down the vector V with our for loop, looking at each value, and if that value is bigger than maxi, then we're going to now make that value maxi and continue the comparison. And the result is that by the time we get to the end, we will have maxi will be the largest value in the vector. So that's the strategy, that's the algorithm. And so do the for loop for x equals V, and we're not going to use just V because we already have x equal to the first thing in V. There's no sense in comparing it to itself, so we're going to use this. We're going to start the second thing and go to the end of V. So that's about, and then if x is greater than maxi, then maxi is going to equal the value x. Okay. And then we end that, and we end the for. Okay. So let's now check this out, see how it plays out. Let me get my windows back right here. See how it plays out. Okay, so let me save it. And put my breakpoints in there. For some reason, it's not letting me run this. Let's see. Oh, it's probably because I didn't finish executing my last one. Okay, so here we go. So now I got my breakpoints in here, so let's watch this thing work. So I've cleared everything, and I stepped through V now equals my vector of doubles here, 26, 42, 87, 13, and 5. Maxi starts off, and it gets the value in the first location in V, which is 26. And then now for x equals V from 2 to the end, which if I put my cursor there, V equals the whole vector, but 2 to the end is going to get me 42, 87, 13, and 5. And so the first value of x will be 42. And now I check, is 42 greater than the present value of maxi, which is 26. So is 42, x is 42, greater than 26? Yes, it is. So I should execute line 10, and now maxi will get the value of x, which is presently 42. And so now maxi changes to 42. I go back to the top of the loop. Now x equals 87. Right? And is x at 87 greater than maxi at 42? Well, yes, it is. So then line 10 is executed, and now maxi equals 87. You go back to the top of the loop. Now x equals 13. And we're going to fail the test here because 13 is not greater than 87. So it skips all the way down to the end. It skips line 10 and all the way down to the end of the loop and goes back up to the top. Now x equals 5. Once again, x at 5 is not greater than maxi at 87. So it's going to skip all the way down to the end of the loop Oh, and I forgot to put in the display. But if I could, let's put in the display. Display maxi. Okay, and then that's not going to work. So let me, if I remove the brakes, then I'll just run it, and you'll see the display down here at the bottom. So yeah, so now 87 gets displayed, which is the right thing to do. Okay, so we execute, you go through your for loop, and then you display the value of maxi at the end. Okay, so now let's look at this same algorithm implemented using the indexing style. And so I'm going to go over here, once again, do the clean slate stuff. You don't have to do the clean slate stuff. I'm just doing it here so that we can clearly see what's going on using the workspace and the command window. Once again, I'm going to come here, call it max, but this time I'm going to do indexing style. And so I say v equals 26, 42, 87, 13, 5. Express that with semicolon. Maxi equals v 1. Express that with the semicolon. 4. And once again, x is not going to equal the vector v. It's going to equal the indexes of the vector v. And since we're going from 2 to the end, then it's going to be 2 colon length of v. Okay. And we do the same thing if x, no, we don't do if x, we do if v indexed at x is greater than maxi. Then maxi equals v indexed at x. Okay, because that's the only way we're going to get the value. In the if, in the for, and this time remember to display the value max. Go. Okay. Okay, so now I'm going to put my breakpoints in here, clicking on these hyphens here. All right, and so let's execute it. Okay, so going through my step, v equals my vector. Once again, maxi equals 26, just as before. But now x is going to equal 2. So now I'm going to index v in the second spot, which is the value 42. And so now maxi gains the value 42 because 42 is greater than the 26 that was in maxi. So now I go back to the top of the loop. This time x equals 3. So now at v indexed at 3 is 87. So now 87 will be greater than the present value of maxi, which is 42. So I will execute line 10. And so now maxi equals 87. Go back through to the top. X equals 4, which v indexed at 4 will be 13. So 13 is not greater than 87. So therefore we will skip line 10, 11, all the way down here to line 12. We'll go back up to the top of the loop. X equals 5. So v indexed at 5 is the value 5, and that is not greater than 87. So we'll skip down to the end once again. And now we're finished with our loop. And so now we will display the value of maxi, which is 87. Okay? So those are 4 examples of iteration and using both styles, the direct access style and the indexing style. Not only did we just see iteration, but we saw some very useful programming constructs in terms of accumulating vectors, in terms of using the switch statement, in terms of finding a result value in a vector, all of which will be useful as you move forward in this class. So this is the for loop for iteration, and continue to work with it, continue to practice, and it should become a very useful tool in your tool set.